The second question that someone had was about atomic radius, ionic radius, and which are you using? Well, first off, to clarify, okay, atomic radius just means the radius of the neutral atom. Ionic radius is the radius of the ion. So looking at this first question here, let me use something other than purple. How about pink? Okay. All right, so atomic radius would be what you would call the radius of fluorine. Ionic radius, what you would call the radius of the fluoride ion. Okay, so the key thing with this, all right, so in comparing an atom to an ion, okay, if we are, right, if we are adding electron, the ion is bigger. And if it's losing electrons, the ion is smaller. And that's of the same element. Okay, so for like this one here, the larger would be well, that was a fail. Let's do this again. Thinking I need a smaller pen. All right, there we go. All right, so larger would be the fluoride ion. Comparing these two iron ions here, right? +2 means it lost 2, +3 means it lost 3. So the one that only lost 2 is going to be bigger. And then let's go look at number 4 while we're in this zone. All right, so here magnesium versus magnesium ion. It lost 2 electrons, which means that the atom is bigger, or the ion is smaller. Okay, so then now when we are comparing both where they're both neutral atoms, then we're going to just use the trend that we learned from where they are on the periodic table. So let me clear this out here from before. Okay, so we are going to compare, I think of the first one, lead versus antimony. All right, so here's lead versus antimony, and it wants, what does it want? Oh, these are all larger. Okay, so here, right, the atomic radius, as it goes down, it increases. And that's because, so here, lead has electrons all the way in the 6th energy level, whereas antimony's electrons only go up to 5 energy levels. So lead is going to be the larger of those two. Oh, I read that wrong. Okay, regroup. Phosphorus versus antimony, my bad. That's all right. Let's try that again. Give me an eraser. All right, so now looking at these two, phosphorus versus antimony, which is what the question wanted, then we would see that antimony is going to be larger because it's got 2 more energy levels in there. So larger is antimony. And then looking at nitrogen versus oxygen, right? Again, 2 neutral atoms. We're looking at the trend, whereas that trend is it decreases. And remember, atomic radius is a pure trend. It doesn't have that little deviation in the trend that ionization energy does. So comparing nitrogen to oxygen. So they both got electrons in the 2p as their outer ones. So not much difference there. However, more protons, right? More protons makes it smaller, all right? So even though it's got one more electron, the fact that it's got one more proton is the thing that's going to make oxygen smaller. So nitrogen would be larger in that. All right, and here we're looking at sulfur, chlorine, fluorine. And I know this may be more than what the original person needed, but I just thought I'd take a little bit of time just in case other people need more information on it or more clarification. Okay, so hang on. Sulfur, chlorine, fluorine. All right, sulfur, chlorine, fluorine. And it wants them from increasing, so it wants small to large. All right, so okay, so which one's going to be the smallest? Well, it's going to be this one because fluorine only has electrons out to the second energy level. So fluorine is going to be the smallest. And then looking between sulfur and chlorine, that additional proton is going to make chlorine a little bit smaller than sulfur. So chlorine, then sulfur. Okay. All right, now looking at this, what do we do when we have a mixture of atoms and ions, and they're not ions of the same element? So all different hodgepodge here. The first thing we'd look at is number of electrons. So more electrons means larger radius. Okay. All right, so let's see, periodic table here. All right, so calcium losing 2 has 18. Sulfur gaining 2 has 18. Chlorine gaining 1 has 18. Potassium losing 1 has 18. Aluminum losing 3 has 10. And argon, neutral, has 18. Okay, so we want decreasing, so we want large down to small. Well, we already know this, the one that's the smallest, that's going to be this aluminum, all right? So I'm going to mark it out as I add it to my list. So Al plus 3 is going to be the smallest. And all right, so now if the electrons are the same, that's when I look at protons. All right, so calcium has 20, sulfur has 16, chlorine has 17, potassium has 19, and argon has 18. Okay, so again, like we said before, more protons makes it smaller because it's pulling more. They have the same number of electrons, but you got more attractive force from the protons pulling it in. Okay, so here, all right, here's another way to think about this too, right? Large is lowest, and this is good to do on a test. Lowest protons. Smallest is going to be the ones with the most protons. Okay, so the largest is going to be the sulfur, S minus 2. It's going to be bigger than, mark them out as I go, 17, chlorine minus 1. Mark that out. 18 would be the argon. And 19 would be the potassium. And then the smallest of those ions would be our calcium plus 2. Okay, so I hope that helped to kind of clarify. That's like a sort of a little bit of everything in that one old quiz that I used for this. Okay, so if you have any questions on this, feel free to email me, and we can do a Zoom meeting follow-up if you need me to do that.